Welcome back. Today, we're diving into the absolute essentials for microservices, the design patterns. Get these right, and you have a scalable masterpiece. Get them wrong? Well, it's basically a house of cards just waiting to tumble. Everyone talks about how microservices give you incredible speed and flexibility, and they do. But here's the catch. Without the right architecture, you're not building a sleek race car. You're building a tangled mess that's just impossible to fix when things break. So what's the secret sauce? How do the pros build systems that are not only powerful, but can actually take a punch and keep on going?
Well, to get the real story, we're going to do something a little different. We're going to be a fly on the wall during a senior developer interview. Let's hear how an 8-year veteran tackles these make-or-break design questions. Let's tune in. All right, let's start at the front door. You've got dozens of back-end services. How do clients even begin to communicate with them? And maybe even more important, how do all those services find each other when everything's so dynamic? Okay, so the first thing you need is an API gateway. It's basically the single front door for your entire system. Every request from a client comes through it. It handles all the routing, sure, but it also takes care of the generic stuff. Authentication, logging, security, so your individual microservices can just focus on their specific job. And then, for everything happening behind that front door, you need service discovery. See, services are constantly spinning up and shutting down. You can't hard code their locations. That's a total disaster waiting to happen. So you use a service registry. Think of something like Eureka. Services announce, "Hey, I'm here," when they start, and they can ask the registry, "Where's the payment service?" when they need to talk to it. So, when you put them together, the API gateway is like the bouncer at the club, and service discovery is the internal GPS that helps everyone find each other inside. This duo is what really makes the whole dynamic, scalable nature of microservices possible. Okay, so communication is sorted, but now the interview is shifting to something even more crucial: resilience. Honestly, this is the part where a microservices architecture either shines or just completely collapses. That's a solid start. But let's talk about when things go wrong. What happens when one of those downstream services fails? How do you stop it from creating a chain reaction, a cascading failure that brings everything else down with it? For that, you absolutely need the circuit breaker pattern. You'd use a library like Resilience4j. It works just like a circuit breaker in your house. You wrap any call to an external service inside it, and it watches for failures. If too many calls fail in a row, bam, the circuit trips or opens. It stops sending requests, which is crucial because it gives that failing service a chance to recover. It's got 3 states, right? Closed is when everything's good, requests are flowing. Open is when it's tripped. All calls fail instantly. Then, after a little while, it goes into half open. It'll send just one single test request to see if the service is back online. If that works, great, the circuit closes. If it fails, the timer starts over. The whole point is to stop your application from endlessly hammering a service that you already know is down. Okay, the circuit breaker is perfect for network problems. But what about a different kind of failure? What if one service just starts going crazy and eating up all the system's resources, like memory or threads? How do you contain that blast radius? Yeah, for that, you've got a couple of key patterns. The first is the bulkhead pattern. The best analogy is a ship. It has separate, watertight compartments. If one gets a hole and floods, the rest of the ship is fine. You do the same thing with your resources, like thread pools. You isolate them so a failure in one area doesn't sink the whole application. And second, you have rate limiting. That one's pretty simple. It's about protecting a service from getting slammed with too many requests at once. You just set a limit on how many calls it'll handle in, say, a minute. So the conversation is getting deeper now. We're moving from resilience to what might be the single hardest challenge in all of microservices: data. Specifically, how do you keep data consistent when it's scattered all over the place? Right, that brings us to the Achilles heel of any distributed system: transactions. The old way of doing things, a simple all-or-nothing ACID transaction, just doesn't fly when you're dealing with multiple databases in multiple services. So, take an example: placing an order. How do you handle that when it needs to update the order service, the inventory service, and the payment service?
You're right, you can't use a traditional transaction. The answer here is the Saga pattern. A Saga is basically a long-running process made up of a sequence of smaller, local transactions. So the order service does its thing and commits. Then it fires off an event that tells the inventory service to do its thing. The key part is this: if any step fails along the way, the Saga runs compensating transactions to undo everything that came before it. So you might not have instant consistency, but you will have eventual consistency.
And there are really two flavors of Saga. You've got choreography, where each service just listens for events from other services and knows what to do. It's decentralized and pretty simple for short processes. Then you have orchestration, where there's a central conductor telling each service what to do and when. It adds a central point of logic, but man, it gets way easier to manage when your process has a lot of steps.
That's a good breakdown. Let's stick with data for a minute. What if you're in a situation where you need to optimize your data models very differently for writing versus reading? Imagine you're getting a ton of incoming data, lots of writes, but you also need to serve up really complex reports that read and aggregate that data.
Oh, that's the textbook case for CQRS. It stands for Command Query Responsibility Segregation. It's a fancy way of saying you create two totally separate models, one optimized just for writing data, the commands, and another optimized just for reading it, the queries. And this pattern gets really powerful when you pair it with event sourcing. With event sourcing, you don't just store the current state, you store every single change as an event. It gives you this perfect, unchangeable history of everything that's ever happened. And you can use that stream of events to easily build any kind of specialized read model you can dream of.
Okay, so what we're really seeing here is that these aren't just, abstract theories from a textbook. They're a real-world toolkit. Each pattern is a specific tool for a specific and very predictable problem you're going to face in a distributed system.
And if you think about it with those analogies, it all clicks into place, right? The API gateway is your bouncer. Service discovery is your GPS. The circuit breaker is your fuse box. And the Saga is your project manager. Each one has a distinct, vital role to play.
At the end of the day, this is what it's all about. Mastering these patterns is what lets you build software that doesn't just work on a sunny day. It's what lets you build software that survives in the real world, where things go wrong all the time. It's how you go from building something fragile to something truly resilient. So there you have it, a quick tour of the Architect's Toolkit for microservices. You've got the blueprints now. So the only question left is, what problem are you going to solve first?